Hey everybody, this is Saumya from DwyerOmega. We get a lot of questions from our customers regarding how to scale and program the DPS20 series panel meter that we have here. And in this video, that's what we're gonna go over, and we'll show you how to scale and program. So stick around and we'll break it down for you right here. The Omega DPS20 series panel meter for load cell signals delivers high performance at 1/8 DIN size for integration in a wide range of weight applications. For the setup, we'll be using an LC103B-1K high accuracy load cell, along with the AC power cord that's already connected to the connector included with the DPS20 meter, and of course our DPS20 series panel meter. We have provided links to all these items and the DPS20 series user's manual right in the description below. Now I'll wire the load cell to the signal connection terminal block. So referring to the load cell's calibration certificate, we can see that the red wire is positive excitation, and that will go to pin 6. The black wire is the negative excitation wire, so that goes in pin number 1. The green wire is a positive signal, so that goes into pin 4. The white wire is the negative signal wire, and that goes into pin number 3. And since this is a 4-wire load cell, I've put jumpers across pins 1 and 2 and the second jumper across pins 5 and 6. So now that we've connected the AC power cord to the power connector and the S-beam load cell to the input connections, now it's time for us to configure the meter. First thing we need to do is get into the menu. So for that, we'll be hitting the square key for more than 1 second. And you'll see INIT, which is the initialization menu, and then we'll hit the square key one more time, and you'll see cell, which means load cell, and we'll be hitting the same key one more time, the square key, and you'll see DP, which is the decimal point setting. So we need to get into the DP menu, so we'll be hitting the square key one more time, and you'll see where the decimal place is set at. For the LC103B-1K, it's a 1,000 pound capacity load cell, so we'll need the decimal place 2 places from the right side. So we'll be using the left key to move the decimal, and we need it right here. So once we have it here, we'll be hitting the square button to save it, and then we'll need to go to the next item by hitting the up arrow key, which is putting in the load. To get into this parameter, we'll be hitting the square key one more time, and you'll see all zeros. So what we need to do now is we need to enter in 1000.00. So we'll be using the left key to switch between the digits. So let's do that now. And all we need to do is just make this 1, so it's 1000.00. So to increase the value, we'll be using the up key. So we'll just hit it once, and it'll go to 1, so now it's 1000.00. And now to save this, we'll be hitting the square key once. Now we'll go to the next item by hitting the up arrow key once. And you'll see nu.u, which is basically the sensitivity of the load cell. To find the exact sensitivity of your load cell, it's going to be mentioned on the calibration certificate, and for this load cell we have 3.0005. To enter that value, we'll be hitting the square button once, and you'll see all zeros. We need to enter 3.0005. So to make the flashing digit 5, we'll be hitting the up arrow key 5 times. So we have 5, and then to switch between the digits, we'll be using the left key. And we'll make this 3. We'll increase the value using the up key. So it's 3.0005. And now to save this, we'll just hit the square button. You'll see nu.u, and the last item we'll need to program is the excitation voltage. And for that, we'll hit the up arrow key once, and then hit the square key to enter. And this LC103B was scaled using 10 volts DC, so we'll change this from 5 to 10 volts by hitting the up arrow key once. You'll see 10, and then we'll just hit the square button to save the 10 volts. Now we need to get back into the run mode, like the main screen, to get the load values from our load cell. So to do that, we'll just hit the left key 2 to 3 times. Okay, now we see there's a 0.42 without any load applied, and that's basically the inherent offset that every load cell has. So there's another parameter that we'll be covering, which is the TARE feature. To get into that menu, we'll hit the square key for more than 1 second. You'll see INIT, and then we'll keep hitting the up arrow button until we see KLE. Okay, here we are. It says KLE. Now we'll hit the square key once, and you'll see TARE, and we'll hit square key one more time, and it says on. that basically means it's already turned on. If you get the meter right out of the box, it might say off, but you can just use the up arrow key to switch between the two options. So now we'll go back to on using the up arrow button and just save it using the square button. That's it. And then we'll go back to the main screen by hitting the left key. So as you can see, there's still some offset coming out of the load cell. So in order to tear that out, we'll just double press the left key to tear it out. As you can see, it just teared out. And then when I squeeze the load cell, you'll see the values change, and that's basically the load that is being applied on the S-beam. And there you have it, folks. We've connected the panel meter and the load cell and have configured it to read pounds for us. And as always, if you have any questions, feel free to reach out to one of our engineering experts at DwyerOmega.com. Thanks for watching, and be sure to like and subscribe.